5 things to get you started fast. And we are, my name is Phil Seamark, and joining me on the stage is Jeffrey Wang. Now, I work for the Power BI CAT team. I'm quite a new member of the CAT team. I have written a book on DAX. Now, I have got 4 copies of this book to give away, which you'll have a chance to win, and I'll explain how you might get a chance to win that shortly. But we're very privileged, and this is a great honour, certainly for me, to share the stage with Jeffrey Wang. Now, I wrote a book on DAX. I'm pretty proud of that. It was quite an achievement. Now, Jeffrey wrote DAX. So we're very lucky. So if you've got any questions, please feel free to try and stump me. I've got good coverage. And I'll explain how you can win the book now. What I have got is I fired up for this session when I can find my mouse. My mouse pointer has decided to just disappear on me, which is not ideal. There is a website called BRK1018. Excuse me, I'm just having a few technical. Here we go. Cool. I know what's happened there. BRK1018.me. This is just a little temporary website that you can go to. You can go to it on your phone, or you can go to it on your laptop. Enter your name here if you would like the chance to win one of the copies of the books that we're going to give away. And if you would like either me or Jeffrey or both of us to sign that, we'll do that for you. When you enter your name, I only collect that for the purpose of the session. I immediately delete it, so that's gone. And let's have a quick look at what the website looks like, so you can see what we're talking about, because this is where you can type in a question into the session as well. So if I type in BRK1018.me, and it's probably slowing down because maybe a few of you are getting to that. You can type your name, and then if you type in a question, it'll appear at the bottom, and you can vote for other people's questions if you like. Now, and near the end of the session, what we'll do, because this is quite a large crowd, we'll go back to that question list and have a look at the top voted questions, and we'll do our best to answer those for you. It's probably a bit slow at the moment, maybe because we're all trying to hit it. So over the course of the session, hopefully we can get some questions in. So this is very much this is an introductory session. We're not going to be talking advanced DAX, complex DAX. This is really designed to be for someone who is either new to DAX or only has just started DAX. So if you have written quite a lot of DAX and you've come along to the session because you know Jeffrey's going to be here, we're not going to go too deep, and that's a good thing. We're going to be gentle. So we are going to be giving you what we think are the most helpful tips to get you underway, and like I said, we're going to be gentle. We are not going to be talking about advanced topics like filter context, other advanced theory. We're certainly not going to be giving you advice on visuals or how to do beautiful report layout. There are some fantastic sessions later on today that you can go to for those. And in particular on DAX, I think we have Peter Myers in this room after us. And anything by Marco Russo would be perfect if you want to get some more advanced stuff. But we're really just going to focus on the basics here. And we're certainly not going to be showing or going through line by line some complex code. If we do show you some code, the point of the code is more to demonstrate a concept or an element of the way you write the code, not necessarily on the functions themselves or that. So that's just to set the scene. So first of all, what I thought we might do is just try and answer a question for you. What exactly is DAX? Who would write DAX? And what would you use DAX for? So perhaps Jeffrey, if I can stop talking for a second, do you want to have a crack at those 3 questions?
Sure. DAX was created roughly 10 years ago. The target audience back then is for business analysts. So back then, Microsoft had a very successful BI product. It's an OLAP engine. It's called SQL Server Analysis Services. But that product is very powerful, still popular today, but it's targeting like professionals who are trained in sophisticated technologies to build a BI product for business analysts to consume the result. So Microsoft was entering the self-service market, and at that time, the first incarnation of the product is called Power Pivot in Excel. And so we're targeting Excel users who are business analysts. You don't need a software engineer degree. You know Excel formulas. That's already a good start. DAX has a ton of functions that directly borrowed from Excel, has identical syntax and semantics. And then you can basically create your own business analytics models and create your own reports and produce the results. So the whole purpose of DAX is targeting end users of a business intelligence, not the old way that you need a professional to do it for you.
Yeah. Cool. And so what is DAX?
Yeah.
Who would use DAX? And what was the third question? What do you use DAX for?
Yeah. Oh, yeah, I forgot that's another. So why do you want to use DAX? DAX, the reason you call Power BI, DAX is the ultimate power of Power BI. So later on, Phil's going to show you a couple of concrete examples where you can use DAX to create tables, columns, and measures. And so fundamentally, you can use Power BI to do a ton of things without writing a single line of DAX. But eventually, sooner or later, you want to produce some results that matters to your business. And there are some specific business rules that you have to write a little bit of code. So that's where the DAX will come into play. And you can start small, start slowly, and eventually you'll find out that DAX is a very powerful language. It has a ton of features built into there. And you will be able to, if you truly want to achieve the full potential of Power BI, you will need to know some DAX knowledge. But there's no rush. You can take your time, and you can already start it without writing a line code and achieve a lot. But over the years, you will be able to leverage DAX to do a lot of very magical things for your business.
Cool. Thanks, Jeffrey. So for today's session, we're going to be using Power BI Desktop for the demos. You can write DAX in other places. You can write DAX in Excel. In fact, Excel is where DAX began its life, and is probably still on the same version that was initially embedded into Excel. Obviously, we can write DAX in Power BI Desktop, and you can also use it in more advanced scenarios if you're coding against the analysis services database. But we're not going to talk about that here. So for today's session, we're going to be using Power BI Desktop. And the 5 elements that we've picked that we're going to walk through are up on the screen there. So we're going to look at basic syntax first, just explain when you start typing, what are the important elements that you need to include in your formula. There are 3 types of calculations. So we're going to have a look at what those 3 calculation types are and when would you use one over the other, and how you can get those in. Variables, a really important syntax or feature that came into DAX, not initially, but later on, is the ability to declare variables and assign values to those variables to use in your DAX formulas, particularly when you're writing more advanced formulas. But it's good to be aware of what they are and how to use them fairly early on. Dates. Practically every data model you're likely to need to work with is going to have an element of working with time. Whether you're reporting trends over time or trying to do period comparisons like this year versus last year and get differences and percentage deltas and those sorts of things. It would be unusual for you not to work on a data model that doesn't have an element of date. So we're just going to talk about some of the handy functions that are designed to make life easier for you there. And then finally, help. So when you get back to your desk and you go, right, I was shown all these wonderful things by Jeff and Phil at the conference, but I've forgotten it all. So what are some good sites that I can go to for free to remember all these things? So we'll go through these things one by one. So basic syntax. Let's start with this. If I fire up a copy of Power BI Desktop, you can see that okay? I can zoom in. I will zoom in. Now, in this Power BI Desktop file that we're going to be using today, I have a data model. And the data model is a set of tables. If I just tidy this up a bit. My data model is reasonably simple. I have just 4 tables. I have a sale. Whoops, I did not mean to do that. I have a transaction table with 1 row per sale, and hopefully you've got a very, very big one of these if you're working on a similar model yourselves. And I have 3 additional tables that we call dimension tables. These are the tables that we can use to slice and dice the data. We're not going to be talking too much about data modeling today. What we're going to be doing is writing DAX to leverage this particular data model. And we can see that in Power BI Desktop in the relationship view. And I mean, a data model is effectively a collection of tables and relationships and calculations combined for you to create reports to let your end user hopefully understand what's going on with your underlying data. So in Power BI Desktop, we have a modeling tab. I'm probably not using the best zoom here. I'll try a different zoom. Okay, that's not ideal. So in the modeling tab, I'll explain to this because the zoom is not working that well. There are 3 buttons that you can click on. You can create a new table, a new column, or a new measure. And for the purpose of syntax, what I'm going to do is just click on New Measure. Now, straight away, it's giving me a dialog area that I can start typing in. So this is where I can create my formula. So Excel will have something similar, and the other tools where you might write DAX are the same. And the first thing it's enabling me to do is give my calculation a name. So anything that I start typing to the leftmost side will be the name of the calculation. Now, you can use spaces. So we can call this Phil's first calculation equals. So everything I've just typed in up until that point will be the name that this calculation will be in the object. So now after the equals sign, I can actually, this is where I start writing DAX. And there's just a couple of important things to be aware of here. We're going to be querying columns or data that exists in columns and tables. So when I want to decide I want to create a sum calculation over a column in my sales table, I need to type in the name of my sales table. And in this case, it's called fact sale. Now, straight away you can see that it's offering me a suggestion there. That this is a concept called IntelliSense. A lot of languages have this. Hopefully it's familiar to you. So this is going to speed up and mean you don't make too many typing mistakes. And a table name needs to have a single apostrophe wrapped around it if it has a space in the name. You don't have to always put an apostrophe around the table name, but if you have a space, and I recommend using spaces because with BI and data models that you're exposed to your end users, using natural language to describe your calculations not only makes life nicer and more pleasant for your end users, but it also plays nicely with things like the Q&A features. So when people are typing in questions like, show me sales for this region or whatever, then yes, certainly feel free to use spaces. Other languages might recommend you don't use spaces and go camel case and all sorts. So if you're referencing a table name, single apostrophes, but they're not essential if you don't have a space. Now what I would like to do is mention the column that I want to perform this calculation over. Now, column names use a square parentheses that needs to be wrapped around the outside of them. So I am going to perform a calculation. So I want to run a sum over a column. Now, the IntelliSense is not offering me a column name in this context. And that's because what I actually need to do is put a wrapper function around this. And the most common function you're likely to need to use initially is something like a sum function. And if you've come from Excel, where a lot of the programming you do is function-based, the syntax is very similar, where you have a function name, which calls the function that you're going to be using, and then you have standard parentheses, the curved parentheses. I think these are described different ways around the world. And here I have sum with open bracket, and depending on the function, you might pass no parameters, you might pass one parameter, you might pass many parameters, and the IntelliSense will certainly help you, will help guide you as to what you should put there. And I'll show you a website, a really good website at the end that you can use to go and find out and get a lot more information about what's required. So if I delete this here, so the sum function in the IntelliSense underneath is saying I need a column name. So to find that column, I'm going to say that column exists in the fact sale table, and my column is going to be called quantity, and close bracket. So that's a basic introduction to the syntax. Now there is one other element that we're going to be looking at today that we'll use. So you can reference a column or a table, but you can also reference another measure. And we're going to be talking about this in more detail in the calculation section. So to reference a measure, you use the square brackets, which is a little confusing because we're using square brackets with columns as well. And you know, if you're looking at someone else's code and you see lots of square brackets, it's not necessarily immediately obvious when that object that you're looking at happens to be a column in a table or another calculation. Some people recommend that if you're referencing a column, you should always put the table name, and if you're using a measure, you should never. I don't think it's so necessarily hard and fast. Do you, Jeffrey? It's just probably good to understand that when you use the square bracket syntax, that it could have one of two meanings. So if I click on the tick box here, this will actually load the calculation into the model, which I'm not going to do. I'm just going to show you the other syntax, that if I was to create a calculation that referenced another calculation, because you can nest these, all I do is just start with the square bracket, and the IntelliSense will probably offer a list of as many other measures or calculations that it can find. So that's the introduction to basic syntax. So let's jump to calculations. So as I've suggested, there are three main types of calculations in a DAX model. Let's start with table. It's probably not the one that you're likely to use the most, but I'm going to create a table because once I've created this calculated table, we're going to add some columns to it and we're going to add some measures to it, so you can see how that works. So for a start, what I'm going to do is cancel out of this. I don't want to create this calculation that I have just made. Again, on the modeling tab inside Power BI Desktop, I'm going to click on a button that says New Table. Oh, it's chopping this off, unfortunately. I might bring this down. That's probably better. I've figured this out now. I'm going to click on the New Table button, and as soon as I click on the New Table button, the area where I can type into appears. Now, often when you look at this for the very first time, it only shows you one line, and it looks like you just have to type a really long formula in a really, really long line. At the end of the dialog box, there is a down arrow here that you can click to give you more space, more room to actually put that in. So the first calculation we're going to throw in is called, when I zoom out and do that again, New Table, paste. Cool. So if we think back to the syntax example that I just explained to you before, the information to the left-hand side of the equals is just going to be what the object is going to be named. So in this case, we're going to create a calculated table called dates. After the equals, now we're into the DAX. And because DAX is functional, there are about 140 functions. The very first function here is called calendar. And then the calendar function expects two parameters to be passed to it. They happen to be, what date do you want to start this calendar at as the first parameter, and what date do you want to finish your calendar at? And in this case, the value I'm using for the first parameter is another function. You can nest functions. You can go crazy. You can because what happens is every single function outputs or returns something, which could be an individual number, it could be an individual piece of text, it could be a table of values. So some DAX functions expect maybe a table to be used as a parameter, and you can use other DAX functions that return tables. Now, when you look at the help that I'll show you near the end, that will tell you which functions return tables and which functions return numbers. In this case, my date function will just return a number, and its 3 parameters are just year, month, and day. So this is going to return the 1st of January 2016, and for the second parameter, it's going to use the DAX function called today that doesn't need any arguments. You'll notice the parentheses just open and close. You still need the parentheses even if you're not passing arguments to it. And when I go OK, when I click OK, what this will do is it'll create a new table in the model with, in this case, a single row of data. If I click on it here in the field list, we can see that the table here has a single column. The very first row in the table is the 1st of January 2016, what we asked it to do, and then this will go 1 row per day until today. And then tomorrow when I refresh the model, it'll have 1 extra row and go on. So this can be one way for you to create date type information into your model. But we're not actually going to use this. I just wanted to show you as a really simple example how you can create a calculated table in your model. Now the actual calculation that I'm going to add to the model is a very, very simple shortcut technique to create a dummy table. And I'm going to create here. I clicked on the Create Table button, and it's going to create a table called underscore measures. The underscore has got the only meaning of underscore in this context is just to put it at the top of the field list, because underscore alphabetically just seems to be higher up than A's, B's, and C's. So when I'm looking at my model and I always want to have see where my measures are, then this will always be at the top. And the rest of the syntax is just creating a single column, single row table with no values in it. It's a placeholder effectively for me to do other things. This is not essential. This is just something that I prefer to do, I like to do. Because when I go OK, and I jump back to Power BI, and I collapse all my tables in my field list, we can see here that my underscore measures table is right at the top there. So the next thing I want to do is let's have a look at adding columns. Now this should be very familiar to you if you're used to working in Excel. And one thing I see people that do come from Excel into learning DAX and Power BI is they do tend to overuse columns. We'll talk about that next in the next section. But I want to show you the basic syntax of adding a column to a table. So I have in my model, when I can find my mouse again, cool. We have a fact.sale table that has a number of columns. Let's say I just want to add a brand new column that's going to have a calculation. On my modeling tab again, I'm now going to click on the new column button. That's going to give me the ability to just type something in the same place that we saw before for the table. And if I drop this down and paste this in and try again, sorry, I must have clicked the wrong key. There we go, cool. Now another nice thing that you should probably do, this doesn't affect performance, is make good use of line spacing and formatting of your code. You'll thank yourself later on when you come back to the same calculation in 3 months' time. You've completely forgotten why you wrote this or did anything. And you can use the Shift Enter and Tab to do things like space out the logic. And you can put as many spaces in here as you need. DAX will not care if you have gaps in your code, and the line numbers are there on the left-hand side just for reference. So when your DAX does get very, very long, and I'll show you some right at the end if we have time. So here we go, we're adding a column. We can see that we're using the syntax notation of the table name and the column name inside the square brackets, multiplied by this here. And when I go OK, what this should do is say, you've already got a column in here called that. I obviously didn't clean this out. So I'm going to create a very similar named column here and go OK. And what a calculated column will allow you to do is very, very easily create a value based on a calculation over on top of other values that happen to be on the same row. And all going well, we can see that I have created, out here on the right-hand side, my new column. If I scroll all the way to the end there we go. There's the column that I've just added, and believe it or not, that the value that has been put into that each cell there will be reflect the quantity in the column used. Okay. So lastly, so we've used calculated table, calculated columns. The other calculation type is a measure. So we'll quickly throw one in, and we'll talk about how measures are different to columns. Because why would you even need measures? You can just do everything in columns like you can in Excel. But they have their place. So I'm going to click on the modeling tab. I'm going to click on the new measure button, and very similar to the others, I will paste in some code that I've got. And this code, new measure, paste that in. Cool. So this is going to create a calculation in the data model that will perform. This is very similar to what I did a little while ago. Now, measures, unlike columns, are very good at transcending rows. So when you add a column to a table, it's got very fast, easy access to other data in the same row, whereas measures are really good at aggregating many, many rows together into a number, like performing counts and sums and averages over your rows here. So here, when I say sum, fact, sale of total including tax, it's going to actually look at every value in the column and give us a number. Now, calculated columns, when you add them to your model, as soon as you click the OK button, the expression in DAX does all the work at that point, generates the number for every single row, adds it to the model, and then it stops. It just doesn't run again. And the model is actually read-only. And then the next day or the next time you come to refresh the model, the expression that we wrote in the calculated column runs at that point. So it doesn't run at the point that the end user is interacting with the report. Whereas a calculated measure doesn't run until the user is doing something in the report. They're very dynamic. So you could have 1,000 calculated measures in your model, and your PBOX file will be exactly the same size. They're sitting there dormant. They're sitting there waiting to be run. And it's only when you drag the measure onto a bar chart or a line chart and the end user loads that page that the code in your calculated measure actually will run. And I've got a simple example that I'll show you shortly. But let's have a look at this, what this looks like on the canvas. So if I drag this measure, and where did I create this measure? I will have to find it. I created it here. I actually created it on the fact sale table. And a quick tip, if you ever want to move your measure to a different table, you just, on the modeling tab, you can reset the home table for that measure to be where you would like it to be. Now, this is a cosmetic thing. It will still produce exactly the same result regardless of what table it sits on. The only difference would be is if you do reference the measure name with the table name, then it will stop finding it. So, but let's drag that measure that we just created onto the canvas. And that's not the measure that I just created. This is the measure I just created, and it gives us a single number, 19 million something. 173 million, which is interesting but not particularly useful. Where it gets useful is where you start combining that measure with other elements in your data model. So if we look for the calendar year, and we set that visual to be, say, a matrix, and we put calendar year onto rows. Now, what's interesting about this is we're now getting a different value per year, but we didn't put any information in our DAX code how to handle that, what to do. So this is where the data model comes in and plays with your calculations to help produce the correct result without you having to write specific where clauses or write a lot of code. You know, we just say, I want to sum this column, and then you let the data model do the rest, so long as you create your relationships nicely. So the other thing I will probably put onto this calculation, we've dragged a field from a date table. Let's go and grab a field from another table, which say state province. So if we put state province onto columns, bang. So now what we're seeing, again, our calculation is producing a very specific and relevant number for the intersecting points of Arkansas in 2015 or Colorado in 2016. You know, but our DAX is simple. It's just, I want to know what the sum of the column is. So they play together very nicely. And in fact, the reason why this works is because we have these relationships here set up. If I remove the relationship between the fact.sale table that I'm trying to sum over and the dimensions city table, which we just are slice and dicing for by our state province, and go back to that visual now, fix this, it's going to create relationships. Okay, what we should normally see is it'll give you the same number over and over again. Cool. So I want to demonstrate a little more about the difference between how the calculated column behaves and how the calculated measure behaves in the table. So I'm going to create another table in the model with the population of a small number of US cities. And what I'm interested in is their population size, and I want to rank them. I want to understand you know, what's the biggest city in the US, what's the 7th biggest city in the US, etc. So I'm going to create a table. I'm going to paste in some code. I'm not going to dwell on the code, but I'm hard coding a table called US cities, and I'm using a DAX function called data table to allow me to create this table, and I'm just hard coding in 3 columns and about 10 or 12 rows here. I can't remember the exact things, and I grabbed these numbers off some Wikipedia population census thing. So this just gives us our base to work with, and if I go OK, I now have in our data model a static table, and I want to add a column which is going to rank those cities by population. So when I find my US cities table, if I click on it and look at it in the data view, US cities, take that away. Okay, so we have 3 columns here with some numbers. And if I go new column, paste in some code, this column, remember the syntax, the name of the column is going to be called rank as column. You can call it whatever you like, so long as it's not a reserved word. There aren't too many of those. And I'm using a function called rankx, and I just want to rank the cities by population, and bang, that'll give me a value of 1 through 10, with 1 being the largest city, New York. Good, that's what I expect. So that's good, but that's static. At that point, that's when the expression actually ran, and the output of the expression now is locked in place. It's as if it had come from maybe the source system to begin with. So what I want to also do is generate exactly the same code, but as a measure this time, the dynamic one that doesn't get stored. So if I grab that code, and it does look quite similar, I'm going to go new measure, paste this in, and OK. So it doesn't live anywhere in the data view. So now if I create a visual over that, and let's drag city name onto a table, population, state, rank as column, and rank as measure, and zoom on in. Now every single value in these 2 columns, so this 3rd column here is utilizing the calculated column. The rightmost one is using the calculated measure, the dynamic one, but they're producing exactly the same number with the exception of the grand total. This is just the one on the 3rd row here is just summing them up. We would fix that in DAX, but for the purpose of this explanation, at this point, they're exactly the same. So why would you use one over the other? Now, The difference comes in is when you start adding slicing and dicing to your visuals. So if I say I want to have a slicer over state, and we've got 3 Californian values, we have 3 Californian cities in here. Los Angeles, which is second, San Diego, and San Jose. So I'm going to grab state, and I'm going to drop it to the canvas and turn that into a slicer. And I'm going to select California, and now let's see what happens to the values. So the column is just reproducing the numbers that were generated 5 minutes ago, those static ones. That calculation's already run. That's actually a really fast exercise when you're doing that at this point. Whereas the measure, it's dynamic. It's saying, oh, I'm going to rerun. I'm going to rerun now, but take into account what the user's done, what buttons they've pressed on, what filters they've done, all these sorts of things. So that's really the introduction to the 3 things. There are a lot of scenarios where they will both be useful. They'll both produce the same number, like the one I just showed to you. And if that's the case, then probably the calculated column is the better way to go. But if you need your calculation to be dynamic, to reflect what your end user is doing with your report, then definitely the calculated measure is a good way to go. But just bear in mind that if you put too much stuff into your calculations, you make them really slow and overload your report, then there's going to be a time cost, a resource cost when your end user's using it. So if you can do stuff with a calculated column, good, but we'll go with that. So the next thing we're going to look at are variables. So I've got some exercises here which, Jeffrey, you're going to have a break from me talking, but Jeffrey can talk through, and we'll do an example in showing you what variables are. So actually, first, what are variables and what would you use them for?
Okay, so variables are so far what Phil has shown you are mostly the functional syntax of DAX, right? Variables is actually the first DAX feature we're going to show today that doesn't look like a function. But the purpose of variable is when you write a slightly more complex logic, typically it takes multiple steps, right? You need to calculate something and then something else, and then you want to combine the result together. You can use the full functional syntax, which Phil is going to show an example, and then you're going to write nest the different functions. You're going to nest the functions inside the functions, and maybe nest the functions in many levels. That makes the code very hard to get right and very messy to look at. So variable is an easy way for you to break your code into multiple steps, very easy to read, and especially you can give variables very meaningful names, and just like any people who have any programming experience, a good name goes a long way to make you understand your logic and debug any issues in the thing. And then eventually you're going to combine the result together using variables. We're going to show, Phil is going to show you several examples using variables. And eventually variables, when you go to the real large data models with like billions of rows, one of the power of DAX is not only it works great on like your daily small models, it actually can perform against a large volume of data. And in those cases, performance can become an issue. And a variable is actually a very good technique you can use to optimize your formula. But that's for the future. For now, let's just show some examples of using variables. And we're going to show calculations that take like multiple steps. Let's first look at the functional syntax, and then let's look at the variable syntax to do exactly the same thing.
Cool. So to start with, what I'm going to do is show you an example that doesn't use variables, so we can see the ugly thing that we're going to try and solve by using a calculation that uses variables. So this exercise, all we're interested in doing is trying to understand per calendar year, what was the percentage difference to the previous year. Now this is a really common thing you're likely to need to do using DAX, just a period comparison. So for the example, in this table on the screen, the middle column is my base column. This calculation is just sum of my total including tax. I'm not going to change that function. The calculation on the right-hand side is the one I'm going to build out, and that's the one we want to end up being this percentage change difference. So to look at it to begin with, at the moment, the rightmost column is just doing this. is just actually referencing the other measure, which you can do. So at the moment, the table is producing the same value in every single row. That's cool. So if I was to enhance this and say, what in DAX, I would like you to actually do something else. I'm going to make you go and grab the previous year value. And we're not actually looking at the specifics of this function. We're just showing, okay, this is working. So at the moment, the rightmost column is now offset by 1. So on any given row, in the second column, we've got that year's value, and in the rightmost column, it's showing the last year value. So we've gone and grabbed the right value. So now what we need to do is do a subtraction over that. Where's my mouse? This is going to slowly get longer and longer. So I'll edit this measure, and I'm just going to paste in my slightly longer code, which is a subtraction. So now what we can see in this rightmost column is the delta. And then finally, the kind of calculation that you might expect is to take that delta value and divide it over the one of the two years that we've got. And this is pretty ugly and hard to read. My copy and paste, copy and paste. Cool. So that's actually giving us, this is saying 8%, 6%, 8%, and negative 1.39. The numbers themselves aren't important. So this is how you might achieve that without using variables. And it's kind of hard to read. We could space this out. But what I'd like to do is show you exactly the same calculation, but now using variables. So I'm going to go new measure, paste this in. Logically, this does exactly the same as the previous one. But what you can see in here, there's a keyword called var, which is short for variable. And we're naming that variable my current year. There's another one just below it called my previous year. And we're assigning values to that. And the expression from this is the same as what I did in the other calculation. But then finally, and this is an important keyword, that when you do use var, you actually also need to include a return statement. And the return statement in this case is a calculation based on our variables, and we're reusing a variable too. And this is where you can start getting performance gains, because my previous example might do a lot more unnecessarily calculations. So if I go OK, and I drag this measure into my matrix, what it should do is produce exactly the same value, but it's a much nicer, easier thing to read that in some scenarios is going to be faster. So definitely look at variables. Another really helpful thing to understand, and I'll get Jeffrey to talk through this, is I'm going to add a measure that uses something called inline variables. So we have a function here called sumx, but this is nested in here. So Jeffrey, can you explain what's happening with this measure?
So if you look at the syntax of variables, you basically say a var, a variable name, equals any expression, and you can have multiple vars, and the vars can refer to each other, by the way. So basically, the second var can refer to the result of the first var, and so on and so forth. And then there's a return keyword, and then there's the final expression, which produces the final value of this thing. This particular structure, basically var, 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 return, and then final expression, all these things will produce either a value or a table in DAX, right? And this structure you can use anywhere in the DAX that expecting a value or a variable. So it's not necessarily a top-level thing. You can do it anywhere inside any DAX expression. For example, and if I look at this DAX expression, what it does is for people who come from Excel side, people always say, how do you do sum if in DAX? And we don't have a function sum if, but you can use a sum plus if nested inside. So in this case, it's a sum x. We call it x means extension to the sum because it's basically have a richer syntax. So the sum x function will go over a table that's called a stock item, dimension stock item. They basically say for each stock item, I want to calculate something and then return the sum back. But in this case, I only want to sum for example, if the profit is negative. I want to sum up all the negative. And in order to do that, I introduce a variable, basically a structure there. So this whole thing, var, return, and if, will produce a negative profit value. And then this value will be different for each stock item. So for each stock item, I will first say var, and I use a variable name called v profit equals, I'm invoking another measure called a total profit, and then it will calculate the profit for this stock item, and then I will say I will return it only if it's a negative. By default, if you don't return it, it's going to be a blank value, so it's like a sum up of a bunch of null values. So it basically doesn't change the sum. So this is a good example to show you that the variable syntax can be used anywhere inside a DAX expression. Doesn't have to be only at the top level, even though the top level is the most like a common one.
Oh, that's cool. So you can actually, you don't have to write variables right at the very outer layer of your calculation. You can sprinkle them inside your calculation. They're very, very powerful ways to allow you to do some pretty sophisticated stuff. So the next element that we want to talk to you about are dates. And as I mentioned earlier, pretty much every data model you're likely to deal with have dates. Now, back in, let me just remember when this was, back in 1582, Pope Gregory XIII came up with the Gregorian calendar to replace the update that previously used Giullian calendar. When he did this, he didn't have business intelligence reporting in mind. He had months that had 28 days, 29 days, 30, 31 days, and they varied. And as you know, February varies within years as well. We have this leap year concept. And in fact, the previous calendar did understand the concept of a leap year once every 4 years, but the Gregorian calendar introduced, let me see if I can get this right, you add an extra day every 4 years, except if that year is divisible by 100, except or unless that year is divisible by 400. I mean, how do you write business intelligence over that? I mean, surely that was actually designed back in 1582 by someone with a job title of project manager. Because that's the kind of weird things they do come up with. We have a weekday pattern of 7 days, and we have these month patterns that don't align with weekdays. So how do you actually bucket these things up into nice, even amounts that for you to compare? And even just things like when I have a date, or if I have a value that happens to be in March the 30th or March 31st, how do I compare that with a date in the previous month? What do I do? Do I go to the 27th? Now, you could write a lot of code to do that, or you could take advantage of this fantastic suite of functions inside DAX called time intelligence functions. And they are designed to simplify your code and solve some of these surprisingly tricky scenarios that can occur with dates. Dates, the more you look into it, the nastier it gets. In fact, in 1752, there were riots in Britain about this calendar. Historians maybe suspect it was the Protestants, considering the Gregorian calendar as a Catholic plot, but really, these were data modelers, and they were angry. They just did not like the calendar, but it got suppressed and we did it. But as I said, DAX can be tricky. So what I'm going to do is just show one simple time intelligence function. Now, one element you must always add to your date-based data model is a calendar table or a date table. And there are some very basic rules that you should follow when you're adding a date table to your model. It should have one row per day. That's it. And don't ever duplicate rows per day. Don't have gaps. So even if you have transactional data that for whatever reason you're a retailer and you don't have sales on a Sunday, that's fine in your fact tables and your transaction tables, but in your date and calendar tables still have a place for that date so that it's got something to work with when it does these period comparisons and cumulative totals and the like. So the time intelligence functions that we have in DAX work best when they're used with a calendar table that fall into these rules. So I'll show you an example of a calculation that doesn't use one of the time intelligence functions. Now this is going to be a year-to-date, a cumulative total. Again, quite a common thing that you would want to do inside a data model. So if I add a calculated measure, and this is going to look ugly. Lots and lots of code, lots and lots of complex code, and if you want to actually understand this, there are more advanced sessions. Go and see Marco's session, for example. So what this is going to do is produce a year-to-date value. And if I jump onto a blank piece of canvas, I can say, show me for every single day the output of this calculation that I've just added, and make that a line chart, because that visualizes it nicely. We can see that at the start of every year, it's just growing to reflect sales. There's actually one little dot per day here. So it's quite a lot that's going on. And like I said, there's quite a lot of code there. But now what I'm going to show you is exactly the same function, side by side, written using one of the time intelligence functions. So we'll go new measure, paste this in, and OK. Now, immediately, far fewer lines. And the function is called total YTD, total year to date. And all I do is pass two parameters. I'm passing the DAX expression I want to do, which is the sum of a column, and I'm just passing in the date. We'll go OK. And I'm going to drag date to a side-by-side measure and add the one that I've just added and turn that into the same type of calculation. So you can see that they're producing exactly the same result. But what we'll do is we'll have a look to see how these perform. So we'll turn on the fantastic new performance analyzer that's shipped very recently. We'll start recording and we'll refresh those visuals. And we'll have a look. How fast did these DAX takes? Now 4.1 is the manual that is the calculation that doesn't use time intelligence. And the DAX there was half a millisecond, 455 milliseconds. That's not too bad. But the one that uses time intelligence was only 100 milliseconds. It was like 4 times faster. And if you have a much bigger model than I'm using here, that's going to really make a difference. So not only is it simpler DAX, but often you can get much better performance out of it too. And even better, one thing you may need to do when you're working with dates is work with things like fiscal calendars, financial calendars. Now, I could go and modify my more complicated one by adding more complicated DAX, or I could take my year-to-date measure and just simply pass in another parameter. And in this case, I'm going to pass in the values of the 30th of the 6th, which is the 30th of June. And now the calendar is starting, believe it or not, on the 1st of July and accumulating from that point. So with a very, very simple addition to that time intelligence measure, I've got financial calendars, no complicated columns or anything like that. So the point here that I'm trying to emphasize is the time intelligence functions that exist in DAX are really useful, and go and look at them. So finally, let's have a look at where you might go for help. And there are plenty of places that you can go for help, but what I thought we would just focus on a couple of sites, aka.ms/DAX. That's the Microsoft reference guide that...
Do you want to put that on the main screen?
Sorry, maybe I should put that on the screen. Good point. Here we go. aka.ms/DAX. So that's the Microsoft site. It's not just a reference guide, although it does list every single function, including the syntax. There will be examples, but there'll be learning videos and guides in there too. So that would be my #1 go-to site. The next place I would recommend is community.powerbi.com. There's a very rich and busy forum section there that you can sign up, post your questions, post your DAX questions. You will get a number of good quality answers. Even if you don't want to post your question, the chances are the thing you're trying to do has already been asked. So go there and find other answers that people have suggested. DAX.guide is similar to the Microsoft reference guide. It's the generated and maintained by Marco Russo and Alberto Ferrari. It lists every functions with details on how to use it, where you might use it. And all going well, when you combine all these things together, variables, nested calculations, hopefully you'll end up doing something like code like this.
Main screen.
And I'm not, main screen, good point. You just combine it all, and I write more complicated DAX than this, what this allows you to do is play tic-tac-toe. So we'll test that theory. Let's put a square there. So I'm playing the X's, the DAX is playing the zeros. Oh, I might go down here. Oh, I better block him off. Now it's going to beat me. Let's just see if he knows to go there. I lost. Oh well. So that's the next step. So what I've explained to you today, you can go home and write this, okay? That's all in there. So we've run out of time, sorry. I've talked far too much. I've got 4 books to give away. So let's just see if we can do that. There are a bunch of questions. So if your name comes up here, please come and see me at the end and we can sign this for you. So I'll just refresh this. The download file for this, including the answers to questions, will be on available on the site. So let's just spin that. So Nathan Giullian, please come and see me at the end. Karen Ford, well done. Ji Hong Feng, and Karen Ford again. Very lucky. How many times did you enter, Karen? And Jeff Young. So if you're still here, please come and see me at the end. We'll sort you out with a book. Thank you very much. It's been really enjoyable talking to you. And enjoy the rest of the conference.